Hey students, we are continuing our study of ratios, and today we are doing 5.3a, unit rates. One thing I want to just start out with this lesson with is telling you that a unit rate is just a ratio that always has a 1 in either the top or the bottom, or one of the numbers in your ratio is going to be a 1. For example, I could say there's a 3-to-1 ratio, or it could be 1-to-3, depending on which way you set up the ratio. But one of these numbers is always a 1. That's what unit means, 1. So let's continue with our lesson. All right, to start out with today, we are going to look at your bell work. And I'm going to change my color here so it stands out a little bit better. So we're going to look at number 1 first, and this one's kind of complex. I mean, it looks more complex than it is. So we have a fraction outside of our parentheses here. And that fraction just means we're multiplying what's in the parentheses. And when I always like the fraction 1/2 because it's pretty easy to see. So what is 1/2 of 12? X. Well, 6x. What is 1/2 of 8? 4. And because this is order of operations, we're following PEMDAS. Okay, we got done with what's in the parentheses. We're going to bring everything else down. That little star means time, so I'm just going to use a dot instead. And then 3 to the second power minus 2x. Okay, now after we do we did grouping, all of this is gone. What do we do next? Well, after the G, if you look at the board in Mr. Roberts' room, you'll see on the right-hand side of the board, you're going to see the order of operations. The letters that are colored, we have G-E-M, or G-E-D-M-A-S. So we are on exponents now. So we're looking right here. So what's 3 to the second power? If you said 6, you'd be wrong. It's 9. So I'm just going to bring everything else down. Okay, so that's gone. We are now to this next step here, and we need to look for multiplication and division. And there is some multiplication here. We can see that right there. So we're going to do this multiplication. 4 times 9 is 36. We're going to bring everything else down. And now we're on the addition and subtraction part. And we are looking for like terms. So the 6x can go with this negative 2x, and then we have this plus 36 that is by itself. So 6x minus 2x is 4x, and then we have plus 36. So there you go. That's the answer to that first one, 4x plus 36. Let's take a look at number 2. For every 4 hours of babysitting, Sam charges $30. If last month she earned $75, how many hours did she babysit? So this is a ratio, and we are comparing two things. We are comparing hours to money, or money to hours. It depends on how you want to set these up. You can flip-flop things as long as you stay consistent. So I always like to put money on top because money is important. So I'm going to put money on top, hours on the bottom. And I know that I get, or this Sam person gets $30 for every 4 hours that they babysit. So we want to know how many hours she has to work to get $75. So that's how I'm going to set this problem up. Now, I'm going to use a ratio table to solve this one, just to kind of show you how to do that. We're going to go with a ratio table. And the first thing that I'm always going to do is I am going to look at the ratio that it gave me, and I'm going to simplify it. So that's what I'm going to do right here. I'm going to simplify that to the lowest that I can. So we have 4 and we have 30. Well, how many, is that simplified? No, it isn't. So we can take a 2 out of it, and we get 2, and we get 15. So for every 2 hours she works, she gets $15. So we're going to put $15 per 2 hours. Okay? So again, money, hours. I want to know, it gives me how many hours for 75. Okay, how did 15 turn into 75? Well, you can use your calculator if you want to. And I do 75 divided by 15, and I get 5. This is a times by 5. So if I take 2 and times it by 5, I get 10. So this answer would be 10 hours. Okay? So that's the stuff that we actually worked on yesterday. Let's take a look at number 3. Number 3, a percent. Percents are actually ratios. It's a proportion. So I'm gonna teach you a couple of different things here. We have part over whole is what it's showing here. Part over whole. Other words that mean the same as part is. Whole also means of. So I'm looking for my of, or my is. 75 is, well, that's the part. I don't have an of, so it's X, because it says of what? Whenever you're dealing with a percent, you put your percent over 100. It gives us the percent, which is 150. Okay, so this is a proportion. I could actually simplify that 150 to 100 and then do what we did on the last problem. Or I can cross multiply and solve for X. So that's where we're eventually going to get. So that's what I'm going to actually do right now is I am going to go, all right, that times that is 7,500. This times this is 150X. Put in what I call railroad tracks or a wall. And now this is 150 times X. So how do I get rid of multiplication? I use division. And because I divided here, I have to divide by the same thing over here. So I'm going to get out my calculator and go 7,500 divided by 150, and I get 50. So my part is 75. My whole amount is 50. So that's how you do that. All right. There's your bell work. Let's move on. All right. This is your notes for unit rate, and it is on page 73. Let's go through these questions, and let's see what we get. Let's see. Number 1, a candy bar has a ratio of 225 calories for every 45 grams. How many calories are there per 1 gram? So when I'm doing unit rate, guys, I'm just going to go like this. 225 divided by 45. So I'm taking the calories and I'm dividing it by the grams, sorry. And that right there will tell me how much it is per gram. So I'm going to go 225 divided by 45, and I get 5. So there are 5 calories per gram. Okay, so what are you really doing here? Well, you're taking that 225 over 45, and you're really doing a proportion or a ratio here. I want to know how many calories per 1 gram. And we just kind of took a shortcut here by just dividing those. But really, if you went 225 times 1, you get 225. And then you get 45x. And then you divide by 45. And you divide by 45. And it goes 5 times. So that's how you got your 5. So you're really doing these steps. But because it's by 1, you can take a shortcut and just divide. And because it is per 1, we know that it is a unit rate. So I guess what they're saying is to shade this all green or whatever, because we know it's a unit rate. Whenever it's per 1, it's a unit rate. Let's look here. The hot dog eating champion of the world can eat 72 hot dogs in 10 minutes. How many can he eat per minute? So we're going to go 72 divided by 10. And that will give me the answer. So 72 divided by 10, enter. I get 7.2 hot dogs per minute. Okay, so I'm thinking that this one is it a unit rate? Is it a rate? It's a rate. Because, let's see here. It's a rate. It would be red because it's not an exact. It's 7.2 per one. So that's why. Number 3, we paid $76 for 8 pizzas. What's the unit price per pizza? Okay, I'm going to go 76 divided by 8. I get $9.50. So put money there per pizza. Okay, and let's do this last one. A 5-ounce bar of gold costs $6,700. How much is each ounce of gold? So I'm going to go 6,700 divided by 5. 6,700 divided by 5, and I get $1,340 per 1 ounce. Okay, so really all we're doing today is we're just dividing the ratio to find a unit rate. Let's move on. Okay, for this first section, I just went through and did the problems for the first part of the practice, and I just want to look at them and let you see how I did it. So on this first one, I had 6 kittens per 3 boxes. I want to know how much it is per one. So you can see that I set it up kittens to boxes. I labeled it. I wrote down the ratio it gave me, and then I wanted to know how many kittens per one. So you can see that I simplified the ratio right here, and then I went, okay, how did 1 turn into 1? I times it by 1, so I'm going to times the top by 1, and I get 2. So there are 2 kittens per 1 box. Now, you can make this a little bit faster by doing, by just knowing that you're just dividing here. So you're really just taking 96 divided by 16. I get $6 per 1 hour. And that's the same for all of these questions right here. That all you're doing is you're taking the number, you're using the label, of course. 72 biscuits for 9. Well, how much is it for 1? 72 divided by 9 is 8. 8 biscuits per 1. And that's how you're doing here. So take a look at those, try some on your own, see if you can get what I get. Now let's take a look at these. On this 9 and 10, all we're doing here is we are just dividing. We get this number and divide this, and we get, if that's the same, then it's a yes, they're equivalent. So kind of going off of what we did yesterday. Again here, I divided, I got that, divided, got that, no, it's not the same. Now we're going to look at the story problems. And the story problems I want to go through with you because it seems like students struggle with these more than anything. So let's read it first. Kathleen, a florist, designs 5 bridesmaids' bouquets with 95 rose stems. She also creates 3 bouquets with 63 tulips for the flower girls. Whoa! So which type of bouquet was designed with the lesser number of flowers? So guys, we're finding a unit rate here. We're going to try and find bouquets. We're comparing the flowers to the bouquets. Okay? So if there were 95 rose stems in 5, well, how much is there in 1? We're going to go 95 divided by 5, and we get, for this first type right here, and I'm going to call it the rose one, so we'll just go rose. There are 19 flowers per 1 bouquet. Okay? For the other one, we'll call it the tulips. We have we're going to go 63 divided by 3, which is 21. So this is a 21 to 1 bouquet. So there's 21 flowers per one bouquet, and it wants to know which one is the lesser number of flowers. Well, we've got lesser here. There's 19 is smaller than 21. So we're just comparing the two different things by finding a unit rate. Let's take a look at number 12. Lightning strikes Earth 1,000 times in 10 seconds. How many times does lightning strike per second? So, because it's per 1 second, we're going to go guys, I'm going to go through the correct way of setting things up. We're going to go strikes per minute. There's my label. I have 1,000 strikes. Oh, it's seconds, not minutes. Sorry. So I better do strikes with ST, and then we'll do seconds with SE. And we've got 10 there. I'm going to set it equal to how many in 1? So X over 1. We want to know strikes per 1. Well, because it's a unit rate, we just have to go 1,000 divided by 10. We get 100 strikes per second. All right, so not too difficult. Yeah, unit rates are pretty fun. Okay, 4 business class rail cars in Acela Express, oh, that's a hard word, has a total capacity of 260 passengers. How many passengers can travel per car? So, I am taking my 260 passengers, and we're comparing it to the cars. So I am going to do, I know that I have 260 and there are 4 cars. So I'm just going to divide. 260 divided by 4, I get 65. So I have 65 passengers per 1 car. All right, number 14. Andre, Rick, and Ty were practicing for a track cycling race. Andre covered a distance of 750 meters in 3 minutes. Rick clocked 4 minutes for a distance of 800 meters. And Ty raced 950 meters in 5 minutes. Who covered the most distance? All right, that's a unit rate. So we're going to do meters per minute. So sometimes you have to write it out because they both have start with the same letter. So I am going to go Andre first. He did 750 divided by 3. He did 250 meters per 1 minute. That was Andre. Then we're going to go Rick. Rick did 800 so divide by 4. He did 200 meters per 1 minute. That was Rick. And then we have Ty. Ty did, let's see, 950 and 5. So 950 divided by 5. He did 190 meters per 1 minute. And that was Ty. So who did the most per minute? Well, that would be Mr. Andre. He was a little bit faster than everybody. Well, quite a bit, actually, for meters. All right, so there's your practice. Let's look at your assignment really quick. All right, guys. So I just looked at this before I started recording. And if you did the practice and you did the notes, we're doing the exact same thing here. So refer to your practice, refer to your notes to see if you're stuck. Or you can always ask Mr. Roberts when you come up to visit with him or your other teacher. All right, guys, good luck. Hopefully you can find some success in doing this assignment. Till next time.